Okay, hello everyone. Welcome to Drupal8 and Internet of Things. So myself, Pratik Jain. I work as an engineering manager at Ixula, and today we are going to talk about uh, Internet of Things. What are different applications? How can someone or any beginner can get started with it, and how you can use Drupal8 along with the different Internet of Things. So thank you, Drupal Hyderabad, for the first webinar. Yeah. So said that, as we'll get started. Uh, so even going beyond Internet of Things, right? And Internet of Things has been recently moving towards intelligence of things. Uh, we are living in the age of intelligent things. Smart and connected devices are almost everywhere, and they're already a big thing and growing exponentially day by day. Uh, Smart connected devices don't just only hand over the data to the human users, but they engage more software or more analysis, which derives more decisions. And intelligent things make human interaction or human action to occur based on the data that we receive. And that's what these Internet of Things is doing. And that's why it's translating into more towards intelligence of things. Uh, Moving on. So these are some of the examples. I'm going to go through some of the examples that you can see and relate to that what is it that it is happening today. And these are some of the applications or the products which already exist out there. This is Happy Fog. Uh, if you're eating too fast and that leads to poor digestion, poor weight control, right? This fog actually tracks your eating habits. If you're using this fog while you're eating your food, it will alert using indicator lights, using gentle vibration when you're eating too fast. So all of that is connected. You get the data on your web portal, and then you can analyze the data uh, on base of it. Similarly, this vessel cup tracks your personal hydration needs. It tracks how much water, coffee, or beer you are drinking. Hydration is dynamic and generally unique to individual and can lead to more energy, better skin, and things like that, right? So you would want to know how much water you're drinking and keep a track of that, right? So you just use this vessel to drink water or any other liquid, and it will track all of your drinking habits. Smart toothbrush. So this is a connected toothbrush connected by the sonic motor, which in turn gets connected by Bluetooth. You can connect it via your family. You can take care of your kids, right? I mean, parents and kids can track their brushing habits and kind of track that. And this takes care of your dental needs. Uh, if you're running in and out of your garage, to make sure your sprinklers are working, your plants are getting enough water or not, this particular device, low node, lets you control your sprinkler system using your mobile phone. So just from your mobile, you can check the water levels and even create the alerts and even enable or disable the sprinkler system. Smart lighting. This is very easy to control. You can just using your iPad or your mobile app, you can pick the color of the light that you want to use, and then you can just make sure your bedroom has a different light, your dining room has a different light, and things like that. Bluetooth enabled insoles. So now, I mean, with this, there is no need to take out your mobile phones while you're walking or driving. I mean, actually, while walking mainly, to check the directions at every lane or every minute for the navigation. This Bluetooth enabled insoles gives a haptic feedback on your soles to turn left and right. It also counts your metrics like calorie, distance traveled, and all via haptics or vibratory feedback. So this is what it exists today. Sense Mother. You can pretty much make any household object smart using this Sense Mother. You can even prevent intruders. You can use cameras, you can optimize your home heating, you can protect your valuables, you can make sure your kids are safe, you can monitor that, you can manage your coffee consumption using this. So it's a very small device which gets connected to anything, and then you can use this Sense Mother to track all of your these things. So IoT is also there in the health sector. So this small device lets you monitor your blood pressure wirelessly. It's connected via Bluetooth. It takes care of your readings, and then doctor can directly monitor you remotely. So just via the app and a small internet connection, you're using your app. Your doctor will have all the reports that is needed and will be tracked. Smart weather station. So I mean, this is more towards making sure your home weather environment is good. You can manage. I mean, you can take care of your temperature, relative humidity, carbon dioxide, I mean, the air quality that you are breathing at your home. So this is more of your personal weather control system or weather station, which lets you and give that data. It's a small sensor which can exist in your room and can give you that data on your mobile apps. Smart tennis racket. So to get the complete tennis experience, so you can, using this, you can actually check your serve ball speed or play time, or I mean, how was your forehand or was your backhand? I mean, was it a top spin shot? What was the impact locator on the racket, right? So those kind of things can be tracked today with the help of smart tennis racket, and this helps you improve your game and reach your personal best. Okay, now said that, right? I mean, these are the few applications, devices, sensors, whatever you call it, right? That exist already. Okay, and said that, right? I mean, so what is Internet of Things? I mean, we have seen these applications, but then still, Internet of Things is kind of mystery to a lot of people, and so just to describe that, right? I mean, it's an integrated system. It's not a standalone thing. It's not something, a software or just hardware. It's an integrated system of multiple things. Internet of Things generally have a monitoring or a sensing capabilities along with the computing capabilities at times. Okay, so most like a firmware or a device or some kind of a sensor that is there, which is sensing the data as well as monitoring it. It may have your mechanical and analog digital machines and objects. So you basically, to transmit the signal, to take the reading, for example, the smart weather station that we were checking, it has some kind of machines to basically translate, or some kind of a sensors to translate the data, read the reading, and then translate that. And it should have a capability of transmitting data over a network. I mean, if you're not able to read the data, it just there sits in the sensor, then it's not of any use. And that's a thing, right? So IoT is an integrated system which has monitoring and sensing and computing capabilities, has an ability to transmit data over a network, and so on. And like I said, right, I mean, it's not just a technology, it's a complex ecosystem, and has industry-specific implications. So today, Internet of Things can be utilized within smart planets to build smart planets. You can build environment sensor, pollution, leak detection, weather monitoring. You can build smart cities, traffic management, lighting control, water management, your bins, smart buildings, your smart homes, AC controls, security, transport, logistics, smart energy, grid monitoring, power sensors, smart industry to make sure your optimized production is there, your robotics is there, smart living for leisure and entertainment, smart health, things like that we just saw in one of the example, the biosensors, the health monitoring systems, the remote diagnostic, right? Imagine a doctor sitting in a different continent and monitoring you and even operating you at times, right? So all of that is Internet of Things, and some of the recent advancement in this area has made that possible, and this is already happening. So Internet of Things is everywhere that you or whatever you do. Okay, and it's almost in the every sector. Said that, right, since it's everywhere, right, by 2020, Gartner predicts that there will be 4 billion connected people. 4 billion connected people, be it mobile phones, be it these smart gadgets, your Fitbit, your any personalized gadget that you have, your smart watches and things like that, right? There will be 4 billion connected people. With what it means is that there is a revenue opportunity of a 4 trillion, which is huge, $4 trillion, which is very, very huge. By 2020, there will be 25 plus million apps, 25 billion embedded and intelligent systems that would be needed, and 50 trillion GBs of data. I mean, which is huge. I mean, there's so much data that is getting produced every day. So like mentioned over here, there are like 2.5 exabytes are produced every day. And just to give you a context, which this is equivalent to, I mean, I can't even read this number easily. So there are so many million songs, 5 million laptops, 250,000 Library of Congress, 90 years of HD video. And to put things in perspective, 1 zettabyte is actually equivalent to 44 trillion gigabytes. Okay, and total amount of data that exists in the world today is 4.4 zettabytes. So, and 1 zettabyte is equivalent to 44 trillion gigabytes. And by 2020, it is expected that the data in the world would be about 44 zettabytes. So you can see the scale at which the data is increasing, the data is getting collected, and so much analytics, machine learning, AI, and all of that stuff that goes beyond the IoT. But said that, right? I mean, IoT is hard. IoT is still hard to do. IoT is off to a slow start, and there is a reason, because it's hard. Gartner predicts that by 2018, almost 75% of the IoT projects will take twice as long as planned. And why is that? Because IoT is not a point solution, meaning you will have to work with different organizations, vendors. You may have software capability, but you may not have a firmware capability. You may have firmware capability, but then not the hardware that is needed, right? So these capabilities are generally not part of a traditional corporate IT DNA, right? I mean, there are very few companies where, and there are very few solution providers which can bring all of this under one roof, right? And that's the reason it's hard. And then therefore you need to partner with different organizations or vendors for your specific needs. So for example, if I want to build a sensor, I would contact someone within the industry who can help me build that sensor, and that sensor will then give the data, and in turn I will then work with a software firm who will analyze that data, and then lastly build the software for the end users who can utilize and then make intelligence or derive intelligence out of that data, right? So, and that's the reason IoT is hard. A typical IoT technology stack would look like this. I mean, so there's a device hardware which has a sensing or monitoring capability. There's a device software which is needed to basically get that reading, sometimes translate your analog signals to digital signals that is needed, or even to communicate. So, and then to communicate, you need to write a software, but then you need to have a communication protocol as well. There has to be something for which you should be able to communicate. We will see in detail, I mean, now what are different types of communication methodologies that is available. Then different cloud platforms that is needed to basically collect the data, and then you build a cloud applications on top of it, which has graphs or visual interpretations or whatever you want to do, and show it to, or derive an intelligence and then show it to your consumers. So said that, right? I mean, so from this point, I mean, I want to describe and show you a problem that we solved, that I was personally part of, that we solved in the IoT space. Okay, and what was the problem? What is the technology stack that we use? What was our solution, and how did we do it? And then we'll quickly see a demo as well, how it actually works in the real time. Okay, so the problem is in Mexico, there are a lot of tanks on the roofs and a lot of gas tanks on the roof. So just like we have the water tank on our roof, in Mexico there are gas tanks on the roof. They also have a gas cylinders that come like in India, but then most of them have a gas tanks at the roof. Now, a typical way to basically measure how much gas is remaining, let's say even in India, right? If I have to do how much gas is remaining in my gas cylinder, I will ideally I will lift the cylinder and just check the weight, or have some sense. Okay, it generally takes about 1 month for my in 1 month I just generally consume 1 cylinder, right? But then in Mexico, since these are on roofs, there is no easy way to monitor that. Okay, there is no easy way how much gas is sitting at the roof. And therefore the problem arises where the gas companies do not really know what the gas level is. So if someone orders the gas, so consumers in the end who basically is in fear, entire system is in the entire system or ecosystem runs in the fearful manner, where a consumer doesn't really know what the gas level is. He or she calls the gas companies to refill the gas, and the gas company has to bring the big truck and then climb the roof and to fill the gas tank. But sometime, or most of the time, it happens that since the gas might have been already 50% consumed and 50% gas tank is already filled, then what it means is that, I mean, for a gas company, it's a wasteful trip. I mean, they just have to make an entire trip just to fill that 50% remaining gas in the tank. So entire supply and demand ecosystem doesn't know how much gas is in there, right? And the ecosystem is running on fear and the guesswork. There is an uncertainty. There's an inefficient order processing because there has to be multiple round trips. So even if I am ordering a gas, the gas company doesn't know if my neighbor might need a gas as well, because they have no idea about the level of the gas that may be needed, or the gas level that exists for my neighbor, right? So if my neighbor calls again in the evening, then they will have to make another round trip. So it's a wasteful trip for them. So which leads to delivery issues, logistic issues, and then the cost. Okay, so this particular problem exists for both gas companies and the customers. they do not have an idea, and both needs that. At the same time, as a consumer, you might be unnecessarily filling up the gas at the tanks, and then your consumption might not be that enough, right? So that's a problem that we identified, and we wanted to solve it, right? I mean, how can we make it easier for anyone to know that gas level, both for the consumer as well as for the gas company? So what we did is we built IoT device. So this project or this particular product is called as a Nube, and Nube means cloud in Spanish. Okay. So what we did, so there are three parts of the solution. There's a task, which is telemetry as a service, which means that any process of recording or transmitting the data remotely, that is called as task. Then there's a platform as a service where the data gets collected. And then third is a software as a service, which acts as an interface to the gas companies as well as for the consumers. So we have built a small device which has a sensing capabilities, which basically sits on these gas tanks on the roof. It gets the reading from the tank, and this particular device has a SIM card embedded within it. This is a 3G SIM card, 3G enabled SIM card, which can connect to any nearby cell tower. It will find the best connected cell tower and use that to communicate data. So it will take the reading. It gives the tank reading, also the temperature as well as the gas density. So which we'll see it in a while how that data looks like. Then it gets translated to the Sierra Wireless. So we are partnered with the Sierra Wireless, where all the data that is generated by these gas tanks, and these, like, just to give you an idea, there are 10 million gas tanks in on the roofs in Mexico alone. Okay, and these devices are reporting twice in a day. The reading of the gas tanks is almost every 12 hours. Suppose that, I mean, once the data is available in the Sierra Wireless, Nube gets that data, and then the data gets consumed by the software, and then we derive intelligence out of it. So there are things like gas level, what is your consumption pattern. If you want to get alerted if your gas level goes below 10%, let's say I want to auto order and do things like that. There are payments, history, the analytics, right? For the gas company, you can build an analytics where you can say, okay, last June we consumed so much of a gas, right? What is the projection for the next year? So that's where the machine learning comes. You use that data analytics and do things like that to predict the gas consumption as well. So yeah, so this device actually looks like this. It has a battery embedded within it. It is, I mean, it can be there within the sunlight and the rain. It is connected to a cell tower with a 3G enabled SIM card embedded into it. And then there is a sensor in here which lets you monitor the gas level. Now imagine, I mean, the similar architecture, right? I mean, the similar architecture that we just saw for the Nube can be utilized for any other domain as well. So if you want to monitor, let's say, something in the agriculture, you want to monitor the pH level of the soil, right? So it's a sensor that would change. It will still send the data to a device to cloud. It will then be consumed by Nube, and the Nube will derive the intelligence out of it and then show it using web portal, mobile analytics, and do that big data analytics and the IoT, BI, business intelligence and things like that, right? So these sensors, the way the data is getting collected could be anything now. So now that we have built this device to cloud in a Nube platform, the only thing that would change is maybe some things on the portal, the way we want to show the data, and the sensors and the way these sensors are sending the data. The rest of the everything is in here. So this is what typically any IoT solution probably would look like. Now, doing a little bit of deep dive into the Nube architecture, right? So this is what it is. So there's a tank. There's a device on it. It sends the data to Sierra Wireless Cloud, which is our cloud platform. There are REST APIs as there. So this is more of a pull mechanism. There's a push mechanism as well, where the Sierra Wireless can send the data to Nube system. This Nube system is basically built in Drupal8. So all of our Drupal user management, device management, which user has which device and what SIM card is associated with that particular device and that user, all of that is managed over here. It takes care of the order management as well as all the analytics. So this entire portal is built into Drupal. So Drupal, so there's a in between this entire thing is currently hosted on Microsoft Azure. I mean, you can pretty much host it anywhere, AWS or any other hosting provider. So we receive the data, this Nube system gets the data, it passes it and stores it, and then in the end exposes the interface to gas company as well as to the system admin for the new way, as well as to the guest company where they can monitor all of their users. And and from the end consumer point of view, there is a the actual user who wants to monitor their guest tanks can do that. And then also there is someone called as an installer who can actually, I mean, this is the person who basically goes on the roof and then install that device. So they also use mobile app as an interface to install it and then maybe check or debug or kind of report any issues, if any. Okay. I hope it's clear. I mean, how it looks like. So we'll quickly see how this works. I mean, I'm going to show you actually the working of the new bay, and you'll going to go through the dashboard around it, right? So so this is the home page. I mean, I'll just kind of this is a login page. This I'm logging in as a one of the guest company admin. So this is my dashboard where I see how many devices I have. So this is a more of a test data that I'm showing you right now. So there are 6 devices which has or 6 tanks which has data less than 10%, or guess level which is less than 10%, 11 devices which is between 11 and 20. There's no devices between 20 and 30, and so on, right? So on the map also I can see which devices. So this red means this is a below 10% level. So as a gas company admin, I know which of my tanks are going below and where there might be a need of the gas. And below I can see the consumption history, weekly, monthly, that what is my consumption in liters that is happening for my entire gas company, right? So this is a data which is very helpful for the gas companies to do. Then there's an order management over here. So any orders that is made by the users goes in here and can be captured over here. I mean, basically, so all the orders. So, for example, for this particular tank, the order was made for 600 Mexican dollars. Okay, and the last thing over here is the consumers. So basically, currently there are no customers less than 30%, between 20 and 30. So I'm showing all levels over here. So these are the customers. So I'm going to show you one of the tanks that I've been using. I mean, this is more like a dummy data that I will be showing to you. So this is one of the tanks that I have. I mean, that is associated with my phone number and my account. So currently, my tank is at 86%. I've set an alert level for the 20%. So if my tank level goes below 20%, it will send me a notification, and it will also place a manual or an automated order to order a new gas. Okay, so for example, right, I mean, so currently the last order was placed on May 4th. So what I'm going to right now do is, I mean, I will just going to simulate this reading where 86% goes below 20%, maybe let's say 17 or 18%, and then kind of use that. Okay, so in order to do that, I mean, I will just log in on my gas admin. So otherwise, I mean, I don't have a real device on my tank, I mean, in India, but then I'm simulating the reading. So this is the kind of a data which would ideally be reported by typically be reported by any device. Okay, so I'm just going to change, let's say, the data to something date to something latest. Okay, I'm changing my, so this is 860 is basically, this is at the level. So 860 means 86%. So I'm going to, let's say, make it 180, which means 18%. This is the temperature. So let's say I say 25. I mean, I can ignore that. This is the quality of the signal. This is the location that is being used. I mean, the cell tower that is being used. So if there is a real device, it will report that. Then there is a battery level, and then there is a the status. Okay. So once I do a submit over here, it has updated the data successfully. So if I go over here and kind of refresh it, yeah, so you can see my guest level got updated to 18%, and the order is also created. Like you can see, the May 5, the order is in the pending state. So I can quickly show you my mobile app as well, where I have received a notification, and how my mobile app also look. Oh yeah, okay. So I'll just quickly open the mobile app, and then I'm connecting my actual phone, Android phone over here. Yeah. So this is my phone. So this is the app that I have. Yeah. Okay. This was more of an ad that comes with Visor, but yeah. Okay, it's taking too much time for my app to get loaded. One second, let me try and go and kill this app and reopen that. Yeah. So as you can see, the tank level 1 is what it is, for which I can see the 18%. I can also see my order history over here. Yeah. So on the 6th May, the order was placed for my tank 1, which is for the dollar. I mean 500 Mexican dollars, and I might have received a notification as well. For some reason, the notification did not came. So it also sends a push notification to the app, describing that the alert level reached below a certain percent, and then it also requires an auto order. So things like that. I mean, all the tanks that I have will be listed over here. I can go to a tank detail screen, which will show me the tank readings as well as the consumption history below over there. For example, I will. So there's some data for this tank. So this shows me the consumption history for my weekly, monthly, or 3 month, and I can build features around it, and language preferences and few other things. So I can also set the alert. So this is where I set the alert for less than 20% and all. So all of this is kind of built in Drupal. It communicates with Drupal using the Drupal REST web services and uses that. Okay, so all of that goes to the Drupal, and then Drupal kind of act as a central interface for everything. Now, so moving on. So this is how we actually built an end-to-end thing where there was a hardware which exists on the tank. Then there is a cloud platform which is Sierra Wireless in this case, and then we have a Drupal to store the data to build the cloud application, and then we have built a mobile application and the web portal on top of it. Now, moving on. So these are some of the screenshots that we just saw. Basically, dashboard screen, the tank detail screen where I see the consumption history. Then my order screen, I can manually place the orders as well using the app. This is my dashboard, how it looks like over here. And then this is more of an individual tank screen which exists, and then it shows me the consumption of that particular tank history and things like that, and all the orders and everything. So this is built using Drupal8 and Angular JS. Now, so now that we have seen the end-to-end thing, right? I mean, how can anyone actually get started with IoT? Okay, so what does it mean to getting started with the IoT? Okay, so there are different open hardware platforms that exist as of today. Uh, Things like Arduino, Raspberry Pi, embedded, ARM-enabled embedded. There's a project Mango. So this is, we'll quickly deep dive into it. I mean, what exactly it is by looking at the Raspberry Pi. So I use the Raspberry Pi as my uh, my hardware, my open hardware that I use. So what is Raspberry Pi actually? So it's a credit card size computer. I mean, it's a very small kind of a chip or a board that you can call it. It's a credit card size computer, right? And it is developed in UK by Raspberry Pi Foundation in 2009. It was initiated by Eben Upton. It is based on the Broadcom chips. It is very, very affordable. You can even order it from the Amazon for about like about 2,500 rupees or so, and you get a full Raspberry Pi kit about under 4,000 rupees, and you can directly order it from the Amazon over there. It runs Linux. I mean, so there are different OS that you can install into it, just like your machine. You have Mac, Linux, Ubuntu, and things like that. Over here as well, you can install anything. Microsoft has also developed a Windows 10 operating system for these newer boards. So you can actually install Windows in this Raspberry Pi as well. It consumes less than 5 watt of the power. I mean, so it's a very, it consumes very less power. It supports full HD video output and the multiple USB ports. So this is how it looks like. I mean, this is what I'm using as well. So I use Raspberry Pi 2 Model B. As you can see, right? I mean, it has 1 GB of RAM. It has a display interface, camera interface. There's a micro SD card slot which exists, which means this is your uh, hard disk. Basically, this is where your operating systems and your data resides. Then there is a full HDMI port which connects you. I mean, you can connect to any HDMI interface. There's an audio jack. These are the 4 USB ports. There's an Ethernet port to connect to internet. The latest Raspberry Pi comes with the Wi-Fi as well. So I mean, I made this Raspberry Pi to a Wi-Fi using a small Wi-Fi USB adapter. I just plugged it into it and made my Raspberry Pi to Wi-Fi. It has these 40 GPIO pins, which is general point input output pins. It has a 900 megahertz quad core ARM Cortex A7 quad CPU, right? So it's pretty much there. I mean, and this is I mean, the configuration is much better than the first laptop that I actually used. Okay, I mean, and it comes in just a very small size. So so this is showing, I mean, so what I did is that, I mean, to use that, and which we are going to see in few minutes as well, that I use Raspberry Pi 2 to connect with a temperature sensor over here. So this is a DHT sensor, DHT 11 sensor. There are a lot of other temperature sensor that comes, and it also can be ordered from Amazon and can be purchased from there. I mean, so it is very simple to connect. These pins over here, basically the red pin is the red wire shows into the power. The black is more towards the it's the output pin, and so on. So so as you can see, right, I mean, this is the actual hardware or the setup that I use. This is what my Raspberry Pi, and this is my breadboard I use to connect it. I just put in the temperature sensor and connected these jumper wires through it. So you can see and you can view how it is exactly connected, and detailed thing can be viewed at this particular URL as with this particular blog. Shows how exactly it works. Then I use from the cloud platform point of view. So remember the initial flow that we saw, where we need a cloud platform to connect the data. So today there are a lot of cloud platforms available. There's Amazon AWS IoT, there's an IBM Bluemix, there's Microsoft Azure, which offers some services, Sierra Wireless, which we use it for Nubay, there's a Google Cloud Platform, there's a ThinkSpeak as well. So these are a lot of cloud platform, which is very easy to start. You can go over there, you can easily build your prototype over there. I mean, it's free to start. I mean, not all of them are free completely, but then it's free to get started and build prototypes. So I used ThinkSpeak. I used ThinkSpeak to basically act as my as a cloud platform. So I just created a small channel. I called it as IoT data. I said that, I mean, I want to store the 3 fields, that which is temperature in centigrade, temperature in Fahrenheit, and the humidity. Then I used the Raspberry Pi. So this is what the interface of my Raspberry Pi looks like when I plug it into an HDMI port and then connect it to a monitor. So this is a complete operating system which exists. It has its terminal. You can build applications using it. You can program applications using it. So I used Python. So I just created a small Python script, which using which I connected my sensor with the Raspberry Pi and then sent that data to the ThinkSpeak cloud platform. So this is what my script looks like. Unfortunately, I am currently, I mean, unable to connect my Raspberry Pi with this machine to show you the actual script, but then I can quickly go to the GitHub and then show you how it looks like. So let me do that. I can show you what script I wrote on my for connecting my sensor with the Raspberry Pi. Yeah, once again, I'm just browsing to my Git repository over here. Okay, I'm just forgot my first IoT project. Okay, yeah, just my first IoT project. So this is an open source project that I have created. So this is a Python script that I used. I'll just kind of zoom in a bit. I'll quickly go through the Python script. I mean, it's very simple to write a Python script. I found a lot of examples out there, and I kind of referred few to create these scripts as well. So these are some of the libraries that you want to import. So there's a GPIO to basically connect your sensor to the GPIO of the Raspberry Pi. You need this library. There's a time sleep that you need. There's a Adafruit library which lets you connect with the sensor. Okay. There's a UI library because I wanted to call an API. So I just created a small function to get data from the sensor, and in that I use the Adafruit library to read the entry. So it reads the data into the centigrade, then I convert that into the Fahrenheit, as well as it gets me, yeah. So these are two things that I get along with it, as well as the humidity that I get from this sensor. Then what I'm doing over here is I'm actually calling a ThingSpeak URL or an API and passing the data to that. Okay, so you can see, right? I mean, just the data which is read every minute from this particular script is being transmitted to ThingSpeak using this API. So I just indicate that API and then try and send all these temperature readings to my cloud. Okay, and how it looks like once that works, right? I mean, so this is how it will look like. This is the public view of my channel. So my Raspberry Pi I was doing few minutes back, right? So it's like it says over here, like at 10:19, my temperature of my room was like 29 degrees centigrade. So it's kind of built this data automatically. All I have to do is just call an API and then pass these information to this. So this is temperature in degrees. This is temperature in Fahrenheit for the same thing. So and then below is the humidity. So humidity about 40 minutes back or about an hour back at my home was like 13, the relative humidity. Okay, so things like that. I mean, you can pretty much create anything. So I just updated this data 1 hour ago. Unfortunately I'm unable to show it to you in this webinar. But then I've posted a detailed blog about it, how exactly it works. So, but this is how it works. I mean, you connect your Raspberry Pi, you write a Python script, you make that circuit using the DHT11 sensor and the jumper wires and Raspberry Pi, and then you start transmitting. You just have to run that script. Okay, you run that Python script to do that. So, so that, I mean, yeah, so that's how it works. I mean, you can pretty much build any kind of an application. You can connect cameras, you can do image processing. Let's say, I mean, one of the cool examples that I was looking into one of the blog is that it connected a camera to the Raspberry Pi, and it was counting the number of vehicles passed from the road which was in front of that particular house. So it was making, I mean, it was just counting every minute how many cars get passed. So it was reading basically using the motion sensors and the camera to get the detail that how many cars passed where, and then every minute they can kind of generate data how many cars pass each minute, and that so forth. So there are a lot of examples, there are a lot of things, there are a lot of applications that you can do and build using Raspberry Pi. So over here, I mean, in this my example, I used Wi-Fi to connect to my connect to the internet. In the Nube, we use the 3G and the 4G, but there are other ways to communicate as well, which is like things like Bluetooth. You can use a device communication. You can use LoRa, which is long range wireless LAN, and another example is Zigbee. So these are the communication protocols and the technologies that can be used to communicate, right? I mean, you can't have Wi-Fi in the field, in the open field. So, and the Wi-Fi is not a reliable way to communicate if there are multiple devices in the field out there, right? So you need to go with one of these other communication protocol, either use a 3G, 4G kind of thing, or a LoRa or a Zigbee kind of a communication protocol. So like I said, I mean, this is what it looks like once you start transmitting the data. It will be shown like this, and you can build graph, and then you can derive intelligence out of it, and you can take the actions on the base of it. Then the cloud application, and this is where the Drupal comes. I mean, once you have the data and all, you can pretty much build anything using Drupal, and that's where the Drupal excels, right? I mean, with Drupal, you can connect to anything. I mean, you can, once you have the data, you can build any kind of an application. So I mean, not related to this project, but then sometime back we created a Google Glass application using Drupal8, right? So you can expose the Drupal REST APIs and then do that. And Drupal8 comes with a lot of REST. I mean, so the rest is in the core now, right? And the serialization module and all of the kind of good stuff is now in the core, which in Drupal 6 and Drupal 7 wasn't in the core. You can still pretty much do that with Drupal 6 and Drupal 7 as well, but with Drupal8 it makes it a little bit easier, and then you can connect to these so many external third-party plugins or interfaces that you want to transmit and then give it to your users. So what does Drupal offers? I mean, it offers a platform for storing the content. It gives a fine-grained user access control. It ships with the REST module in the core now. I mean, like I said, it wasn't there in the Drupal 6 or Drupal 7. And then it offers content as a service. So you can pretty much create, create a service for any particular content, and so on and so forth, right? I mean, I'm not getting into deep dive into how to create the REST APIs in this particular session. There are a lot of tutorials out there, and then where it makes it so much easier to create those REST APIs on the Drupal8 over here. These are some of the references that I used for creating these presentation, as well as creating the DHT11 sensor and the Raspberry Pi integration over here. So for any questions, I believe reach out to me directly over an email or directly anywhere, and or Twitter. And so this is what I'm a small brief about Ixula, that I work for a leading e-commerce company who have brands, and retailers globally, and things like that, right? And so this is about me. So myself, Pratik, again, just reiterating about myself, working as an engineering manager at Ixula, and we have and helped build that New Bay project, which got me interested into this IoT, and we are trying to set up an IoT lab within in-house Ixula. So that's one other thing that we are trying to do. So once you get into it, you will try to understand how exactly it works, and we are trying to set up the entire end-to-end thing within Ixula as well. So thank you very much. Thank you for attending the session. I mean, for, like I said, for any question, do reach out to me, and thank you for attending. Thank you.